Geometry 6-4, rectangles. So we're going to copy a little bit and then we're going to do some examples together. Rectangles are parallelograms with 4 right angles. So a rectangle, it's just a parallelogram with 4 right angles. So all 4 angles are 90 degrees. And then let's look at this section here. Oh, well, we'll just keep going. Opposite sides are parallel and congruent. Sound familiar? Opposite angles are congruent. Consecutive angles are supplementary. That means they equal 180 when you add them together. Diagonals bisect each other. So this whole section here is the same as every other parallelogram. Notice for the rectangle though, all 4 angles equal 90 degrees. That's a little bit different for a rectangle than every other parallelogram. And also, diagonals are congruent. The whole thing diagonal from one angle to the next. The diagonals are congruent. So, let's do some examples. So if I have a rectangular field or park, and I've got P, Q, R, S, and I have a path that goes from Q to S, and I have a path that goes from P to R, and I've got a little tree over here, I've got a little tree over here, I've got a park bench right here, maybe. All right, in the center here, we're going to say T is where the 2 paths cross. All right, PS is 180 meters. PR is 200 meters. What is QT? So let's see, can we figure this out? All right, PS is 180 meters. PR is 200 meters. Okay, so this one is 180. This whole thing is 200. QT is this one here. I need to figure out what is this one. Okay, so I know this is a parallelogram and it's a rectangle. And I know that this diagonal bisects this diagonal. And I know that this diagonal is congruent to this diagonal. That means that all of these pieces are congruent to one another. So that means QT here is the same as PT and is the same as TR. QT is the one I'm looking for. PR is this whole thing, 200 meters. If QS cuts PR in half, then I know that PT is 100. And I know that TR is 100, and ST is 200, and TQ or QT is also 100 meters. Now you try one. The same schematic here. I want to know what PR equals, but I'm going to give you a different measure for TS. So ignore these measurements here. We have a new measure. TS from here to here is 120 meters. So what is PR, this whole one? So remember, ignore these numbers. They no longer pertain to this question. These are new numbers here. So TS is 120 meters. What is PR? Okay, go. Let's see how you did. If TS is 120, that means that SQ is twice that, which is 240. And that means PR is also 240 because PR is congruent to QS. So 240. All right, let's do one more you try. I am going to draw a rectangle very similar to the one that we just did. And this is P, Q, R, S. Okay, let me kind of delineate that one goes on. So here's this one. Measure of angle PRS is 64 degrees. What is the measure of angle SQR? Whew. All right, let's see. PRS, that's this one right here, is 64 degrees. 64 degrees. Now, I want SQR. This is the one I want, SQR. Remember, each of these is 90 degrees. And now we have to figure out, okay, which ones of these correspond to one another here. So, if I know that this is congruent to this, these two sides of this triangle are congruent, right? Then that means I have an isosceles triangle here. And that this means that's 64 degrees here. And if these are the same size as these ones, and this is a vertical angle, meaning these two angles are congruent, then I have another isosceles triangle here where 64 and 64 are the angles here of this triangle of this base here. So that means this angle here has to be the same as this angle here, because this is 64 and this is 64, and so these are complementary angles, meaning that when I add them together they get to be 90 degrees. So 90 minus 64 equals 26. So this is 26 degrees. Here's another way to look at this, probably a little bit easier than what I just went through. But if I go 64 and I find out that this is 26 degrees, I can see that here is an isosceles triangle as well. And so these two sides are congruent, these two angles are congruent, 26 degrees is what we got. All right, let's do another example. And this one I have another rectangle. And this is rectangle JKLM. And I've got diagonals here and diagonals here. There we go. And the point where the diagonals cross is P. Measure of angle KJL is 2x plus 4. Measure of angle JLK is 7x plus 5. Find x. All right, we're going to do this one together, and I'm going to give you a u-try that is similar to this. So KJL, that's this angle here. And JLK, that's this angle right here. Okay, so those are the two angles we're looking at, this one and this one. I need to find out what x equals. Now, this configuration of angles is just like we just did up here. Notice how 64 and 26, these are complementary. So these two are complementary as well. This one and this one, this one and this one are the same. So therefore, this one and this one are complementary. This one, this one, this one, this one. Okay, these two are complementary angles, meaning when I add them together, I should get 90 degrees. 2x plus 4 plus 7x plus 5 equals 90 degrees. 7 plus 2 is 9x, 4 plus 5, 9. Look at all these 9s. Subtract 9 from each side. 9x equals 81. Divide, oops, I wrote 18. I said 81 and wrote 18. Divide by 9, x equals 9. That's my answer. All right, let's see what you can do here on your own. Here is another rectangle. This is RSTU, and we've got diagonals, and this is point P, Now, RP is 3y minus 5, and US is 5y plus 1. So RP, that's this part here, 3y minus 5. US, that's this whole thing right here, is 5y plus 1. I want to know what y equals. So this might take a little thought here, but I believe in you. Okay, go ahead and find out what y equals. Go. All right, let's see how you did. So RP is this half of RT, right? And US is the whole thing, so in US and RT are the same. So RP, I would need 2 RPs to equal 1 US. So I'm gonna write that out. 2 RPs, which is 3y minus 5, equals 1 US, which is 5y plus 1. I'm going to just distribute. 6y minus 10 equals 5y plus 1. Subtract 5y. And I'm also going to add a 10. And I get y equals 11. All right, let's do a little bit more here. One more example, and this is quadrilateral. PQRS, where P is -5, +3. Q is 1, -1. R is -1, -4. And S is -7, 0. So I've got a quadrilateral. Is this quadrilateral a rectangle? Okay. Now, in order to find, so I could graph this, and I would see a rectangle looking thing, but I wouldn't be super sure that it was a rectangle, depending on my graph. So it would look close to a rectangle, but I can't say for sure. Remember, a rectangle has opposite sides that are the same. So I would need to use the distance formula to find whether or not the sides are the same. So I would say, is PQ congruent to RS? And I would have to say, is PS congruent to QR? So I'd need to find the distance for all of those sides and see if they are congruent. Now, I also would need to find some slopes, because these could be congruent and it could be a parallelogram, but not a rectangle. Slopes. If the slopes are perpendicular, so my slope of PQ, if my slope of PQ is perpendicular to QR, then what should my slopes look like in relation to one another? So if I have a segment that's going like this and a segment that's going like this, and this is 90 degrees, what should my slopes look like between these two? Remember, if they are perpendicular, oops, sorry, I drew that down too far. Here's what I was drawing and showing you and going like this. If my two line segments are perpendicular, then what do I know about these two slopes? These two slopes need to be opposite reciprocals. These two slopes need to be opposite reciprocals. We're going to, I'm not going to go through all of that work here on this video. I'm just going to talk about what each of these entail. So remember, the distance formula is a square root of x2 minus x1 squared plus y2 minus y1 squared. So on your homework, if you find something like this, then you know you need to do the distance formula for each of these sides, and you need to do the slopes as well. So remember, the slope is y2 minus y1 over x2 minus x1, and the slopes need to be opposite reciprocals. Now, when you do the distance formula, it's okay to just leave whatever you get in the radical. It's fine. So for instance, when you do the distance formula for PQ, you should end up with a square root of 52. And so if you do RS, just take it to the square root, to the radical, and see what you get. And so instead of, you don't need to put it in the calculator, you just need to make sure that they're the same. And that is what we're going to do for this video. I'm not going to go through the distance formula and the slope formula here. We've done that a bunch on other videos. That is how you find out if this quadrilateral is a rectangle.